So when we talk about big data, there is a concept that you need to know about, which is the difference between causation and correlation. So I guess for people who come from the economics background, you guys must be very familiar with this, right? For example, Nick, you got economics as your undergrad degree, right? So you must know that in economics, like people care more about causation than correlation, because if we want to study a phenomenon, we want to understand what are the root cause of a phenomenon, right? Okay, I will get to one example later. So one example of this difference between causation and correlation is that, like think about like many years ago, a retailer ran this analysis using the purchase data of their products. And then they found that there is a high correlation, high and significant correlation between the diaper purchase and beer purchase. This grocery store decide to put diaper and beer together because they know that from their historical data, these two products sell together, right? So they put these two products together on the shelf to further boost the sale. So here, can you think of any reason why diaper and beer are correlated? Because it seems that they are just unrelated, right?
You got to bet, you got to drink at home.
Yeah, Jennifer knows the story. Yeah. So here, when we see that, okay, diaper and beer, they are correlated, it doesn't mean that the consumption of beer caused the rise in the consumption of diaper, right? Because there's actually no direct relationship between the two products. The true relationship is, as Jennifer mentioned, is actually usually the mommy asks the daddy to go out and get diaper for the baby, right? So the daddy go out and run errands for the mommy, and then on the way they just pick up beer. So actually here the causation is the dad goes to the supermarket and buys things, right? So this is a very classical story about the difference between correlation and causation. So now here the question comes, as auditors, when we try to identify fraud, actually we by standards we want to understand the causation behind anomalies or outliers. Okay, I think I want to introduce another story and then talk about this. So I just mentioned the story of diaper and beer, right? So the second classical story that is more related to today's situation is about Google's ability to predict a pandemic. Like years ago, Google flu trends, they analyzed people's search queries on Google about the symptoms of having a cold, such as coughing, runny nose, and other symptoms. And they were able to predict more accurately and more timely than the CDC about the advent of the flu season. So basically, Google flu trend is not analyzing the causation of a flu, right? So if you look at the causation of a flu, you look at the germs, right? How the germs transmit and whether you touch your face, right? So these are the causations of you getting a disease. But they just analyze people's search queries and correlate with that with the coming season of the flu. So this is a very typical or a classical success of looking at correlation rather than causation. But there's a debate of whether correlation is enough for us to understand a phenomenon. Actually, the method of looking at correlation or exploring the data is conceptualized by Professor Tukey as exploratory data analysis. This means instead of considering the causation behind a phenomenon first, you can explore the data, like find the correlations inside the data, and then move on to consider the causation part of the story. So for example, in his book, actually I got this slide from Professor Miklos. There is when we go to buy anything, especially during the Christmas season or Thanksgiving season, we know that there is a sharp discount or huge discount on anything. So original fee is basically the original price of the product, and actual fee is what you actually pay. So they run this correlation between the amount of discount that you have with the original price of the product versus the correlation between the discount and the actual fee. So basically, for the first diagram, there's no obvious relationship between discount and original price, right? But there is a positive relationship between discount and actual fee. So in their book, they mentioned that, okay, from this easy correlation, that can help us form a hypothesis, and that is maybe the extreme negative discounts are caused by abnormal actual fees. So this is just one example of how we can utilize this correlation to help us form potential hypotheses and then further confirm the hypothesis. And back to accountants and auditors world, auditors can use correlation type of analysis to identify abnormal phenomena, right? For example, this one. And then you can use that as a signal to further direct you to consider what causes this abnormal phenomenon. So that is to say, we need to have a combination of this correlation and causation.